This is really, I call it the Theresa Melvin show. So I'll kind of introduce, take a minute or two. We'll probably have a few more joining. So I'm Danny Bedgood. I hope you guys can see me. I am with Aerospike. I spent 20 years at HPE roughly. Before I joined Aerospike, I've been here 4 years. Done a couple of things. I ran a global group, built a global verticals team around the world the last couple of years, the last year and a half roughly. I've built or worked with our strategic and enterprise business. So I'm vice president of our enterprise and strategic business. And in North America, my secondary role is really to lead the HPE partnership. We kind of changed that objective about 2 months ago. So Theresa and I are your main contacts with HPE going forward. So any questions you have or things you need business-wise, reach out to me. Technically, obviously, reach out to Theresa. You'll have our contact info. If you don't, let us know. One quick housekeeping item as we kind of launch here is put the questions in chat as we go. We'll have some Q&A at the end, but I know some people will have questions with slides as we go through those. So just put those in the chat window and I'll share those with Theresa as we kind of go forward. So with that, Theresa's going to talk today about powering GenAI solutions with Aerospike on HPE Systems, how to architect that. She's done really well at that with a lot of you already, but we want to share it in more detail and let her kind of walk through that. And I know we have a technical audience, so you guys will have very deep questions for her, which she can help with. So with that, I'll hand it over to Theresa. And again, questions in the chat, and we'll go from there. Theresa, it's all yours.
All right, thanks, Danny. So I thought we had 30 minutes, and I found out that we actually have 60 minutes. So that's pretty exciting because I've got like 40 slides here and a short video. And so I think most of the people that have signed up for this already know me. And the ones that don't, I'll briefly introduce myself. So my name's Theresa. I am an AI pipeline developer. I specialize in exascale, which means the clients that I work with, they are already landing hundreds of petabytes of data, or they are dealing with exabytes of data stored in a geo footprint. Likewise, they are trying to ingest greater than a terabyte per second. And so these are people who have very, very hard problems to solve. So they are typically calling me because the tools that they have are not solving their problems. So they're looking for tools that can solve their problems. And so these are AI ops, ML ops, and now LLM ops use cases. So that's what I do for a living. I am not a database person. And so everybody is asking me, what are you doing at Aerospike? And I have so many messages in my LinkedIn. What's going on at Aerospike? What are you doing at Aerospike? And that is what this webinar is all about. And so I am super excited to be doing this. And so this is our agenda. I was contacted by the Aerospike team the first part of this year when they said, "Hey, we've got vector," and I'm like, "Oh my goodness, you guys have generative AI," and so I. Having come from HPE and specializing in AI, I knew what that meant, and so I wanted to really think about what that meant for Aerospike, because this is a very special product and a very special company. So I wanted to make sure that it was placed properly. So with regards to the benchmarks that I specifically did, there's going to be a white paper that's going to come out on this, and but a little bit about Aerospike. So this is not a database talk, but I have to put this talk in context. So Aerospike, it has 2 tiers of storage, which allows it to scale incredibly incredibly well, and it performs at a level of scale that nobody else does, which allows me to use it in a way that Aerospike doesn't even realize it's being used at. So it stores indexes in memory, and the data is stored on disk. And so they have a patented hybrid memory architecture, and it allows it to store petabytes of data. And the company itself honestly has no idea just how far it can scale to. And so this is what's really quite amazing about this tool is I'm probably the only person in the company who knows just how far this product goes. And I use this product for the last line on this slide because it is written in C. And the clients that I work with specifically look for tools that are battle hardened and written in C. And so because of this, everything in red is what I use, and everything in blue is what my clients specifically need. So everything on left, in red, if we read this slide from left to right, I have to be able to build AI pipelines that are ingesting everything. Every single data source on the left, that is what I am ingesting in real time in just a single pipeline.
Hey, Theresa, this is Jeff here. Sorry to interrupt. We are not seeing your slides. We are seeing you.
Oh, you're not seeing the slides at all?
Correct.
No, actually, no, none of the slides were up as you were talking earlier. It didn't come to the main screen.
Oh, okay. All right. Well, fine. That's all right. So the HMA slide is the first slide in the deck, and so this shows Aerospike's unique two-tiered architecture. So this is their patented architecture, and so the three founders they designed this. It's incredibly robust. And this is their distributed design. What makes Aerospike incredibly unique is it's written in C. It's fully distributed. It uses sync and async, and so it's fully synchronous between. So everything between the servers stays between the servers, and then it's asynchronous wherever it goes outside the servers. So it is unbelievably fast. This is pure high performance computing at its core. So when we get into the Aerospike stack, this is what's important to my work right here. So I come from high performance computing, and so I'm continually looking as not just me, but anybody who is also an AI pipeline developer. We're looking for tools that are built with a C backbone, and this is because we need to be able to work with C as much as possible, because when we build for specific layers of we build for specific tiers, performance tiers. And when we have to build for a milliseconds matters use case, so the fastest tier in the performance stack, it has to be in C. And so if you take a look at the data sources on the far left, everything out here is what we are ingesting in real time. So this is why you're quite literally landing a terabyte plus per second. And then if you look at the data sinks on the far right, the only thing we are landing in at this point is S3. That's it. That's all anybody cares about anymore. Everything else is pretty much obsoleted. So we have to ingest at a terabyte plus per second, and we have to sync into S3 compliant storage. And everything else in there, we have different performance tiers. So we have our sub millisecond performance tier, we have our second performance tier, and then we have our minute plus performance tier. And so I have used Aerospike for my sub millisecond performance tier since like 2016, and it has just never failed me. It's been rock solid for years, and so it's evolved into considerably more than a key value store by looking at the top of this stack here and the data values. So when I started working with it, it was just key value. And it slowly evolved into a document store by adding, they added their JSON and their 2D spatial. And then about a year and a half, 2 years ago, they added graph, a property graph database. And now they've got a vector database, which is beta and slowly working its way to GA. And so this is purely a CPU-based product, but it is phenomenally robust, and I'm probably one of its biggest fans. And so then if we look down at the bottom here, one of probably my favorite things about Aerospike is I build hybrid. There's no way to work at exascale and not build hybrid implementations, which means I build for every single cloud vendor. I build for cloud vendors that Aerospike doesn't even support, and IBM. So my PhD is in quantum, which means I work with IBM's quantum cloud, and because of that, I do QNLP for quantum infrastructures. And so I run Aerospike in IBM's cloud, and I terraform everything. I use one Terraform stack, and it runs from Ubuntu, it runs on Red Hat, it runs in every single cloud. And it's point, click, and implement, and it doesn't matter. And so it's very, very simple. And the other thing that is equally important is their smart client implementation. So this is crucial for me because of the work that I specifically do. Again, every single pipeline that I build, because I have milliseconds matter use cases at the forefront of my clients' what they care about, they begin with C, which is why it's circled in blue. However, for graph, because property graphs are most important to industry, the front ends for those are primarily C# implementations, which is why that has green. So I really have to focus on C# for the front end for my property graph implementations there, which Aerospike also supports because it has that Gremlin interface. For AI/ML, that's predominantly Python. So Aerospike also connects directly into Python. Phenomenal. And then Node.js, which and Java as well. I'm not real strong with Java, so I don't have that circled there, but I on that because I do React work, and I can also do the Node.js work as well. So I've got that circled as well. So I have the ability to do everything that I need to do with Aerospike. It has the community implementation. So because I focus on open source first and community development, I have the ability to meet that objective because I focused very, very much on training the next generation and using community development tools as much as possible and giving back. So Aerospike again meets that objective. These slides that I included in here, I talked about them in the stack, and they go over the products that are included in the Aerospike footprint. These are open source tools, which again is why I'm a big fan. They're integrated in from the open source projects, and they accommodate tremendous scale. So this is the Tinkerpop implementation of Gremlin. This is the community, the open source implementation that Aerospike adopted, and this is the property graph implementation of Gremlin. So you'll notice that I didn't actually mention Spark on the left, and that's intentional. This is because I am specifically talking about property graph implementation here, and not so OLTP versus OLAP. It is a forklift upgrade to try and go from Spark graph implementation, so like RDF implementations, versus property graph implementations. The two do not typically coexist in the same architecture. So like Spark is academic and government is typically where you would find those graph implementations, where Gremlin would be more industry focused. I do work with both, but I want, they're typically for different types of use cases. And so I usually don't do talks on both at the same time. Likewise, I would never encounter a customer who would willingly attempt to try and implement Spark with a Gremlin backend, unless they had absolutely no other choice. It would be like a forklift upgrade. Like that would be a top-down mandate, and they would have some very angry developers. So it just wouldn't make a lot of business sense. You'd have to redo all their code, and it would be a miserable experience. So as far as vector goes, this is, wow. Yeah, so it's new, it's beta, it's not GA. I just get to play with it, and I don't even get to play with it a lot because I'm technically not really a developer here at Aerospike. So I work with the DevRel team, and it's impressive. And this is not written in C. They've written this front end in Java, and it is same principle applies. So everything they do, this is very much an engineering company, and so the decisions are made with an engineering first mindset, which for somebody who is an engineer, I value that. And so it affords tremendous scale, which is going to go into their HNSW footprint, which again, I don't even know how much time they put into thinking out this design. But they separated the indexes from the actual storage again in this HNSW design, which there is one other vector database company that actually does do this, and they are kind of the incumbent in the vector field. And but Aerospike absolutely, from what I've done in performance comparisons between the two companies, is considerably faster, and all in all, it's definitely impressive. I am looking very forward to testing it on more performant hardware, and it will be really interesting to see kind of what the next phases are in this field here. Yeah, so this is not GA yet. It'll be more appropriate to go into deeper conversations on this when it is GA. And but yeah, so as far as generative AI, Aerospike again is more product focused. I don't want to go into too much detail on this until the company has made a decision on what direction they want to go in. But for the work that I specifically do, and the accounts that I do at, I'm going to go into some detail on some of the projects that I've been doing. So this is the team that I've been collaborating with, and I just want to go into some introductions for that team. And so on the left, we have the federal team. So we've got Kung, we've got Rick, and we've got Kim. And on the middle here, we've got the DevRel team. We've got Tim Fox, who's the Chief Developer Advocate. We've got Danny, who did the intro at the top. He heads up the entire HPE relationship, as well as all the strategic relationships. And he also is the VP of North America Sales. And then we've got Art, who is the Senior Full Stack Developer, and he's truly kind of my right hand, where I do GenAI for GPUs and CPUs. Art knows the full stack solution for Vertica inside and out. I'm sorry, Aerospike inside and out. And so he actually built the retail and the RAG demos here end to end. And he actually packaged these up inside the Docker containers and got these ready to go for these for this webinar. So these links, you can actually click on them and you can pull them down. And for the demos that you're about to see here and the actual performance benchmark that I'm going to showcase, it's all because of Art. So he worked night and day to roll this up so that I could actually showcase this and present this present these results in this webinar. And so the stack that that Art actually used with this RAG demo pipeline here was so this retrieval augmented generation pipeline, just to help you understand what that is. So this is going to go through, and this is just scraping just Aerospike documentation. And this is going to embed a Nomic AI model, and it's using an 8K context window, and it's using 64 to 768 dimensions. So it's got a small footprint, and then it's going to vectorize the chunks. It's going to capture that semantic meaning, and then this model is going to generate those embeddings on that actual query as well. And then Aerospike is going to actually do that hierarchical navigational small worlds, and we're going to do the you're going to showcase that speed at scale, and so we're using a cosine similarity search, and we're going to see similar chunks basically in action for this LLM. And for the LLM, it's using Google's Gemma, and we're using a 7-byte instruction model with an 8K context window, and it's quantized to a float 16 value. And then for the application, it's all Python, and it's using UVcorn as well. And
Theresa, quick question. The PDF you had some links in it. Are those going to be live and shared with the audience?
Yes.
Yes. Okay, good. Thank you.
Yeah, absolutely. And for the multimodal pipeline, so this is comparable to the rest of the webinar content, which we're going to kind of go deep dive into graph rags. And but this is going to leverage a key value and a vector demo, and I'm sorry, a vector and a graph demo. And this is going to leverage the traditional Aerospike key value data store as well. So we've got 3 tiers of storage in this. It's got graph, it's got vector, and it's got key value in it. And so in the demo, it's actually a video, and I'll explain the video to you, but I wanted to just highlight the differences in a screenshot real quick. So on the left, what we have is we have an unnamed cloud vendor, and so in this demo, it just runs. It runs 24/7. Anybody in the public can hit this demo. Anybody in Aerospike can hit this demo, and so it's continually cached, and the performance is the best that we are ever going to see. And so for the word handbags, the best performance we're ever going to see on this cloud demo is about 14.235 milliseconds. And so on the HPE Alletra 4110 storage server, this Gen 11 version, with just me basically re-executing this query over and over again, the very first time I executed it, I achieved somewhere around 65 milliseconds. That's right after the data set loaded, the very first time I brought this up, and the very first time I searched for handbags. And so then I ran several other searches, and then the best query results that I got, I think it was somewhere around 8 milliseconds, but the screenshot I captured, it was 9.49 milliseconds. And this is a 1U box. So theoretically, the more processing power you have, the better these results are going to get in theory. So I did run more benchmarks, and these benchmarks are going to be released in a white paper that I'm actually working on. And so those benchmarks actually use an internal Aerospike AS Bench tool. That tool is written in C, and it was intended to drive the actual drives on this Electra storage server. And so I'm not presenting those benchmarks in this webinar, but what I wanted to just highlight is the portions in blue here. And so this is just taken from just publicly accessible data on HPE and Aerospike collateral. And so the Electra 4110, it can, it delivers exceptional throughput up to 500 gigabytes per second of network. So these servers had 200 gig network cards in them, the Gen 11 servers, and the client servers had 100 gig cards. I think I had five or six servers each, and each one had a single 100 gig card attached. And I believe I had multiple NICs in each client. Needless to say, I had no problem saturating bandwidth on those. So that's just a teaser of what's to come in that white paper. So very exciting stuff. It was a lot of fun running that test. So this is the benchmark, and I'm just showing you in this video here that I am running this on two completely different servers. The retail demo DNS is the cloud, and the IP address is the actual Electra server. And so what you're going to see here is just some real easy, and eventually I will get this cleaned up, and you'll see more complex queries. But these are just the real easy softball queries that I did here, just showing you just real quick, simple response times, just differences between the cloud and the bare metal HPE server. And so this is 17 milliseconds for the handbags, and then 14 milliseconds for the black pants versus 10 milliseconds on the bare metal for the black pants, and then 10 milliseconds for the handbags, and then the best I got was 14 milliseconds for the handbags on the cloud. And then eventually I switch over to the I believe it's going to pop up with, red shoes. And so with these red shoes, I just start flipping around through this catalog, and again, this retail demo, anybody can pull this down. Art packaged all this up in a Docker container, and this is the fastest and easiest way to just fool around with Aerospike. You're going to get everything. You're going to get the whole stack. It's got key value, it's got graph, it's got vector, it's got a client, and it has everything self-contained in a Docker container. You can run it on your laptop, you can run it in the cloud, you can run it on a server, and you can run this entire demo. So this is just a Kaggle data set. The only thing you're going to pull out of this Kaggle data science data set are the images. You're going to pull the metadata and the images, and so what we're doing here is just showcasing just the response times, and that's it. So just going back and forth, just looking at just how fast it is on the bare metal versus the cloud. And so here it knows the difference that cayenne is a variation of red, but what it doesn't know is that if I add the word dress shoe in here, that messes it up. So this is showing that I would have to go in and I would have to do fine tuning on this RAG-based algorithm. And so instead of coming back and saying I don't have any cayenne dress shoes, it just comes back with all black dress shoes. But even and this is a variation in the algorithm between cloud and bare metal. Why do I have one gold dress shoe on the bare metal? I would expect the exact same results. So this right here is where the developer, the prompt engineer, would go back and do fine tuning on the algorithm. And so this is what I wanted to show you, which takes us into kind of the next portion of the presentation, which is going to lead us to cases.
Theresa, real quick, couple questions.
Of course.
Is Aerospike developing their own LLM, or are they trying to use OpenAI or open source model?
So that is why I stopped the discussion. I stopped the discussion here, because that's a product question, and I don't answer product questions for Aerospike. So all that I can say is Aerospike is coming out with Vector, and I specialize in generative AI, and that's all I can say.
Okay, yeah, thanks. I was going to join there too. There's a lot of things we're working on that we can share and not share at this point, so I'll kind of leave it there. Another one is just a couple. Is there a cost comparison between cloud and HPE offerings? I might can handle that one, but you go ahead, Trace.
Yeah, you might want to tackle that, Danny. I'm technical. I don't do money questions.
Yeah. So being with HPE for 20 years, we cost comparison is very hard to do because a lot of your customers and ours buy cloud at a rate that's not published. So it's hard to kind of get that gauge of what's on-prem and what's cloud. And that's hidden behind the window. I've had some customers share with us both sides. What I will say is a lot of customers in the last year or so, and we all kind of know this, ingest and movement of data in and out of a cloud is becoming extremely expensive. And it's at a point now to where we're trying to join data on-prem with cloud applications and usage in a mix, so to speak, in an architecture that way. Some customers are going more on-prem, but think of it as more of a mix, so to speak, at this point, and they're trying to figure out how to connect and move the data in and out. One other question, Theresa, has testing been done using HPE Slingshot technology?
So the answer to that is I know Isidro is on the line, and so I'm going to say I can't answer that because it's confidential.
There you go. And Isidro, if you want to answer, if you're on, we've got one more. Oh, he said eventually yes. There you go. So I'll read it out to everybody.
So the problem here, guys, is that everything that I did at HPE with Aerospike falls under confidentiality, because I did it all under COVID, and so most of so Slingshot was just coming out, it was like beta when I was at HPE. So anything that I would have done cannot be discussed.
Got it. One more, and I'll give you the floor back. So what additional features were added to the existing Aerospike architecture to support Vector? Would you say that this is the better Vector DB than other incumbents?
So Aerospike's Vector right now is beta. So I'm gonna answer that as no, it's not better yet. It's beta. I am here to make it the best that the world has ever seen. I mean, that's why I'm here. But it's beta.
And I'll hand it back with one comment. So yeah, that's why Theresa's here, because AI for us is a very large, moving, growing market, and I'll kind of leave it at that. With the way we move data, I kind of do this, the top right corner of real-time data movement where Aerospike sits. AI is right there in that top right corner. So we're seeing a lot of customers come to us and ask them, have Theresa give them how would AI look on top of Aerospike. So All right. I'll hand it back to you. Thank you, Theresa.
Absolutely. Yeah. So graph rag. All right. So we just discussed RAG. I gave you guys a demo of RAG. RAG is vector. All right. So vector databases. Aerospike has vector. Aerospike has graph. So what you have not seen yet, and I do not have a demo of it, is graph with RAG, and that is a monster. That is a behemoth. That is typically something that we see at exascale. Those are exascale problems. That is memory intensive. That is high compute. And those are really, really ugly problems. I see those all over government. I see those public sector. I see those in private sector. And that is where my line of work merges between public and private sector. So these use cases here, retail and travel, manufacturing and energy, regulatory heavy versus non. At exascale, especially for me as an AI pipeline developer, I usually use different icons for these. I usually use an airplane. I usually use an oil rig, and I usually use an operating table for regulatory heavy. And the reason I use those three graphics is because for my private sector verticals, the work that I do is milliseconds matter for these use cases, because lives are on the line in the private sector use cases that I am building for. And they overlap with the public sector vertical use cases that I'm dealing with, such that I'm dealing with human trafficking, I'm dealing with military battlefield use cases, and health and life sciences, so drugs. So same thing, such that lives are on the line, milliseconds matter. So this is why I say, for me specifically, the use cases overlap. So I went ahead and I wanted to make this more, I wanted to make sure that this applied more to a broader audience. So I used different graphics, and I made sure that I could make it resonate more with a broader audience, more than just a milliseconds matter crowd. Because I get it, a lot of people out there, they deal with seconds, they deal with minutes. Not everybody has a milliseconds tier in mind. So retail and travel, these are still very much natural language processing, natural language understanding. They're natural language, they're multimodal use cases. These are the most complex use cases to build. These are audio, these are video, these are images. So when you stream these in real time, these are not generative AI. They're generative AI downstream. They're generative AI on the back end. They're not generative AI at inference. What you're doing at inference is you're providing a probability calculation for the most part. And so, customers a lot of times will run into trouble, especially, they'll run out of money a lot of times if they attempt to do inference using an LLM in these use cases. And so what they fail to realize when I deal with my big travel and retail customers here is you can't rip out your traditional AI and and substitute generative AI. Generative AI is a piece of the puzzle. It is not a rip and replace. So this is really, really important. So this leads into manufacturing. So digital twinning and safety and lockout. This is computer vision. So lockout, tagout use cases where everybody's using cameras. So for OSHA, companies will get fined if they have an appliance or some sort of machinery where during cleaning or that, if it's not properly locked, and somebody were to go into it and incur an injury, they could get fined. The company could get shut down. They would incur, some type of an outage. They would suffer financial harm or brand harm. And so because of this, they're using cameras, computer vision, and so AI models. And so for a lot of these, even digital twinning, so they're using AR/VR devices and mixed reality, where they're actually, trying to do maintenance on machines that are out in the field, planes that are in the air, ships that are at sea, without taking anything offline. So if a sensor reports an alert, then they are trying to actually debug it without taking any downtime. Can it be fixed without taking an outage? So these are the types of problems that we're actually working on right now, and generative AI is a part of the use case. So these are actual graph RAG problems, but they're a part of the AI pipeline. So we use traditional techniques, traditional AI techniques, as part of the AI problem, as part of the AI pipeline, and graph RAG assimilates into that. For regulatory heavy versus non, then we have to really focus on the public LLM versus does the customer need to build their own LLM? And so what people don't realize a lot of times is that embeddings. So a lot of times they want to enrich these data sets using their own data, but if you're going to use a public LLM, you're still going to go out there and those embedding models, if you use their key, it's still going to go out there, and you're still sending your data out there to them to enrich that model. So this is a problem. If you don't want to do that, then you would have to build your own foundational model. That's a heavy lift, and a lot of companies aren't up for that. So what is the alternative then? And so these are a lot of questions that companies are up against, and nobody really knows the answer to that. And so there's a lot of questions there. Companies have data quality issues. We have data trust issues. There's all kinds of legal questions. We have privacy issues. There are so many problems in the LLM space right now. And then we have public sector verticals that we go into. So we have more and more problems just dealing with the regulatory problems that I talked about with data sovereignty, where we have to look more and more at federated deep learning, where mobile phone apps, we're actually doing model training right on the phones because the data can't leave. So all the customer data with all these apps, it sits on the phones. So because we can't move the data, we're training models on the phones. And so we are complying with data locality mandates. And so we're only sharing the training weights, but these are super complicated AI pipelines to run. Again, these are milliseconds matter use cases. And so then we move on to government and education, where we have all kinds of highly complicated human trafficking use cases, and where we have online harm leads to offline harm use cases. And we have, you know, all these images, we have podcasts, we have memes, we have emojis, where you have child porn, and you have drug trafficking, where you know, these harmless memes and emojis, they suddenly are not harmless in these worlds. And you have to have subject matter experts who understand these. And so it's highly complicated when you build AI models in these sectors. And then you have military and autonomous. Holy cow, this is where you truly have to understand performance SLAs. This is absolutely a milliseconds matter, microseconds matter, nanoseconds matter world. This is high performance computing meets high performance computing meets science fiction. So this is super niche development. And you have to understand everything. You have to understand how automobiles move. You have to understand how human beings think. You have to understand how quickly a human being responds when it hits the brakes, how long an automobile needs to actually stop before it hits the bumper of another vehicle. There's so many things that come into play under the sea, in the air, everything. So these are just a few of the use cases, and that I personally work on between Fed and well, I should say public and private, but public sector is not just is health and education as well as federal. So very complicated.
Theresa,
yes.
Just a quick time check. I think we have about 12 minutes left, so just let you know.
Excellent. Okay, so I'm going to breeze through this. So legal AI is a classic graph rag use case. So I'm an attorney. This is where I spend a considerable amount of my time, because this is the courts. They've been trying to solve this problem for a decade plus. And so billions of legal case docs, they're trying to get them all scanned in. They don't know what to do with them. LexisNexis alone has a 3 petabyte corpus. And the Federal Courts of Appeals handles 50,000 cases annually. And so, you know, if they got all this stuff in, if we stored it as vectors, they would have, you know, they're like, what would we do with it all? And so then they've got people like me out there. Okay, so, you know, you would build a knowledge graph with this. Okay, so that's conceptually quite simple. However, it's incredibly difficult to build that correctly. And then if you did, it would be really, really difficult to scale that, because they're you know, they're most of those tools, they're in-memory tools. But Aerospike is not. Aerospike, again, the indexes are in memory, but the data goes to disk. So you could have tremendous scale with that. However, knowledge graphs, they're limited because they don't reason. You still need the ability to reason. And so then knowledge graphs, they still don't have a visualization layer built into them, which makes them somewhat useless unless you're just sending that data downstream to another computational tier. And if you do need viz, then they typically overwhelm the system because you don't have enough memory resources. So then we need a knowledge graph. So this is the actual knowledge graph use case here. So on the left, we've got all those docs that we basically feed into a Gremlin query, and we build our docs. We've got all of our documents, concept, and pages. So we've got our edges, and we build our chunk IDs, and then we build our visualization here with all of that. So this is all of our computation on the right, and then on the left, to build that actual visualization, that is a resource hog between CPU and memory to do that whole thing. So then we do graph rag. And this is differentiated because, unlike rags, which are probabilistic, so it's basically a guessing game, I think the relationships between these concepts and scenarios are right, but it's not entirely sure. Graph rags, they're deterministic. So it's pretty sure it's right. So this enables new scenarios, new use cases. And so now we're using considerably less data. So unlike a rag, which is probably going to use somewhere between 50 and 100 terabytes, a graph rag is going to use about 10% of that. But you still have to know how to architect that graph properly, and you still need a visualization layer, which means you still need a considerable amount of RAM, and you still have to have a lot of storage somewhere for all this data that you have to build, this graph from. So now this is our new design. So on the left, we've got all of our graph ID chunks. We extract all of that. And so now we've got all of our vectors nice and neatly ordered. We store all of that into our vector database. We create our SQL prompt, which is, will this case be disposed on appeal? So we build our foundational model, or we're either building that from scratch or we're using somebody else's public LLM. And then we are enriching that through our building our own fine-tuned RAG. So we're saying if A, then it's going to be affirmed. If B, then it's going to be affirmed in part and remanded in part. If C happens, it's going to be dismissed. And then C.1, C.2, blah, blah, blah. If D, so on and so forth. And then we're going to basically tokenize, do our embeddings. Then we're going to write that to our vector database. And we're going to build our own enriched data set. That's what we care about. And then it's going to give us a wonderful answer with a probability ratio. That's what we care about. That is our inference right there. That number, that 84.94%. That is our value. That is priceless. Nobody else can build that. That's what we care about. That is the value of our business right there. And so this is incredibly hard, I'm not going to lie, because everything that you see there and that's highlighted, this is what GraphRug does. It looks not only for the named entities, but for the relationships of those named entities and the strengths of those named entities. You don't get that with RAG. It's very, very hard to do. GraphML is perhaps the most hardest type of machine learning to actually master. The second and the easiest is basically exporting those graph relationships and then just syncing that into a vector database. But you have to make sure that a master graph person actually created those relationships to begin with. And there's just not a lot of people that really command graph language well. And challenges for developing GRAGs using public LLMs is it's incredibly expensive. I've already kind of hit on this. And high resolution photos, those tiles are even more expensive than the number of tokens that it costs. And then the constraints, so security alone. Most of, if you care about your data and not wanting it to get out, you're not using a public LLM, and then anybody who's in a regulatory heavy environment, they've got regional constraints, and then a lot of customers that I work with have latency constraints and additional derivative constraints as well. So yeah, and then we've got all the solutioning characteristics here. So as far as the work that Isidro and I have done, it's all HPC. So we've got everything is scale up, everything is scale out. It's all specific to GraphRag. It's all end-to-end AI pipeline related, where you can split it however you need to split it, such that you can put graph on half of a node. You can put key value on an entire node. You can put spatial where you need it. And for RAG and fine tuning, you can use an entire chassis. You can use multiple chassis. You could do inferencing on an entire frame. You can scale it out where needed. You can scale it up where needed. But the solutions, Isidro and I have worked in this field forever. And so, I mean, we've architected both, these for ages. So for Aerospike V7, this is all new to V7, graph, vector, LangChain connector, Elasticsearch connector for true multidimensional spatial. It's optimized for GeoJSON, unified storage, LRU cache implementations. We also use ScaleFlex for it's fully configured for ScaleFlex and optimized. So with CSS 3200, it's got the microsecond latency, the nanosecond end-to-end transfer times, and billions of transfers per second. We maximize egress performance, line speed offload to S3 compliant storage on the Electra, and ultra-dense scale out for petascale. And then what I personally love, and you can't do this with anybody else's platform other than HPE, and I know because I work with everybody's high performance computing, is the unique ability to ingress in one transfer protocol and egress in another, especially to an alternate like liquid cooled versus air cooled data center. I can't do this with anybody else's technology. This is absolutely unheard of. And this is why I absolutely love this platform for pipelining workloads. So ingest TCP/IP into CSS and then egress to supercomputer in a liquid cooled data center via InfiniBand. This is so cool. So that's it. Yeah.
Theresa, one quick question.
Yeah.
We got like a minute left.
Yeah, of course.
Does Aerospike choose Gremlin as its query language, and do you support GraphQL or SparkQL?
So it supports Gremlin, so G.V, and GraphQL is coming. Not Spark yet. Yeah.
Cool. I know there may be other questions. I know you know everyone. I would hope has Theresa and mine's email and contact. If not, we've got a list. We can get that to you. But with that, I really appreciate everybody joining. I know there may be other questions, so reach out. But I appreciate your time in joining. I was going to say that because I know the team we have joining us from HPE is the technical guys, and your calendars are jam-packed. Again, I spent many years there, so I completely appreciate your time. So thank you very, very much.
Yeah, thanks, everybody. I appreciate it.
Thanks, everyone. We'll close the call now. And then again, if you have any questions, reach out to us directly, and happy to help and engage with on opportunities. Thanks again. Have a great day.